Good noon to everyone. Today discuss about IPC instrumentation and process control. Unit number 9 frequency response analysis. In previous lecture में આપણે જોઈ ગયા some introduction part and fortune circumstances. Now the part of the generalizations and the transportation leg. Okay, the start will be this point generalizations. Some discussion about equations for a nth order linear system માટે જોઈશું આપણે. તો સ્ટાર્ટ કરીએ. Generalizations. At the point it is necessary to ascertain whether or not we may generalize the result of the last section to other system also. This can be done by checking the result of second order system. Okay, Laplace transform function માં આપણે g of s is equal to 1 upon tau s plus 1 જોઈએ હતા અને કે y of s upon x of s. Now the second one જોઈએ ગયા હતા this basis for using this equation of part. Okay, and third order system etc. However, it is more satisfying to prove that the general validity of the result as follows. The reader may be is if desired accept the result as general and skip to the example 16.2 જે આપણે ઓલરેડી જોઈ ગયા છે. 16.1 16.2 જોવાના છે. We remark here that an important restriction on these rules is that it applies only on system whose transfer this function yield and stable the response. Okay, as nth order linear system is characterized by an nth order differential equations. Okay, now again repeated this one for a generalization system. In a previous section માં આપણે introduction જોઈ ગયા છે, then fortune circumstances બી topic જોઈ ગયા છે. Now this part is important, this basis. At this point is necessary to ascertain whether or not we may be generalize the result of the last section to other system also, and this can be done by checking the result for second order system and third order system also. We can, however, it is more satisfying to prove the general validity of the result as follows. In a third order, the reader may be if desired accept the result as general and skip to the example 16.2 એ જોઈશું આપણે. We remark that here that an important restriction part this rule is that it applies only the two systems whose transfer function yield and stable responses also. And nth order linear system is characterized by nth order differential equation an dn d raised to n multiply y by dt raised to n plus a n minus 1 d raised to n minus 1 y by dt raised to n minus 1 plus up to n સુધી plus an dy by dt plus a0y is equal to x of t. Write down your notebook most important equations, this one. Now to discuss this equation part. First of all, write down these equations. Is a nth order system is characterized by this nth order differential equations. Read it, then write down in your notebook. Which is the part is a generalization. Okay, then what is y? So where y is the output of variable and the x of t is the forcing function or input variable for a specific cases of example 16.4 refer to the equation 5.5 for a first order system and equation 8.4 જે આપણે આગળના યુનિટમાં જોઈએ છે. For a second order system, if x of t is a sinusoidal, again repeated, what is the y in these above equations? This one, the y is the output variable and x of t is the forcing function or input variable. For a specific cases of equation 16.4, refer to equation 5.5 for a first order system and equation 8.4 for a second order system if x of t is sinusoidal and x of t is equal to a sin omega t. Okay, the solution of example 16.4 will consist of a complementary solution and a particular solution of the form. Which one is this equation below? The yp of t is equal to c1 sin omega t plus c2 cos omega t. This is the write down here second equation in your notebook. First of all the 16.4, then 16.5 for this discussion below. This one. X of t is equal to sin omega t. The solution of equation 16.4 will consist of a complementary solution and a particular solution of this form. So yp of t is equal to c1 sin omega t plus c2 cos omega t. If the system is stable, the roots of the characteristic equations of 16.4 all the lie to the left of the imaginary part axis and the complementary solution will vanish exponentially in time. And then y of p is the quantity previously defined as the sinusoidal of frequency responses. If the system is not stable, the complementary solution grows exponentially and the term frequency response has no physical significance, and because yp of t is inconsequential, this problem for equation y of t is equal to c1 sin omega t plus c2 cos omega t. Okay, if the system is stable, okay, is a system is stable, the roots of characteristics equation of 16.4 all the lie to the left of the imaginary axis and the complementary solution will vanish exponentially the time the y of p in the quantity previously defined as the sinusoidal of a frequency response case. If the system is not stable, the complementary solution grows exponentially and the term frequency response has no physical significance because yp of t is inconsistent. The problems now is the evolution of c1 and c2 in equation 16.5. Since we are interested in the amplitude and phase of yp of t, the equation 16.5 is rewritten these equations. Okay, which equation for a yp of t is equal to c1 sin omega t into plus cos c2 cos omega t. In this basis, which is the equations? This one, y of p is equal to d1 sine omega t plus d2. Okay. Yp is equal to d1 sine omega t plus d2 as was done previously. Compared to this equations 5.23 and related equations, it will be convenient to change x of t and ypt from the trigonometric to exponential from using the identity. Okay, the sine theta is equal to e j raised to theta minus e raised to minus g theta by 2j. The x of t is equal to a by 2j in a bracket e raised to g omega t minus e raised to j omega t is over. Now from this equation 16.6, okay, which equation? 16.6. This one, yp is equal to d1 sine omega t plus d2 as was done previously. Compared to this equations 5.23 and related equations, it will be convenient to change x of t and ypt from a trigonometric to exponential form using the identify. Okay, the sin theta is equal to e raised to g theta minus e raised to minus g theta by 2j. Thus x of t is equal to a by 2j in a bracket e raised to j omega t minus e raised to minus j omega t. 16.6 na equation basis परती yp of t is equal to d1 by 2j in a bracket e raised to j omega t plus d2 minus e raised to minus j omega t plus d2 કેમ કે આપણી પાસે વેલ્યુ છે એની. Now equation 16.7, 16.8, 16.4 yield basis for this equation. So write down in your notebook. These are very long equations. First of all, write down these equations. The d1 e raised to j omega t plus d2 by 2j in a whole bracket an in a square bracket j omega raised to n plus a n minus 1 in a bracket j omega raised to n minus 1 up to plus a1 j omega plus a0, this bracket is over, minus d1 e raised to minus j omega t plus d2 by 2j in a bracket a comma minus j omega raised to n plus a n minus 1 in a whole bracket minus j omega raised to n minus 1 plus up to plus a1 minus j omega plus a0 whole bracket is completely over is equal to a by 2j e raised to got by e raised to j omega t. here j omega t આવશે, this is some mistake, this one. Okay, write down this in your notebook. This is equation 16.9. Now continue. The coefficient of e raised to j omega t on both side equation 16.9 must equal for this equations 16.10. The d1 e raised to j d2 in bracket an j omega raised to n plus a n minus 1 in a bracket j omega raised to n minus 1 plus up to plus a1 j omega plus a0 is equal to a. And equation 16.10 will be satisfied if any only if in a whole bracket 1 by an in bracket j omega raised to n plus a n minus 1 j omega raised to n minus 1 plus up to a n j omega plus a0 is equal to d1 by a plus 4 by 1 by a n j omega raised to n plus some base same equations is equal to d2. Now but d1 by A and D2 are the AR for phase change phase angle of these responses, and respectively as may be seen from the equation 16.6, and the forcing function furthermore equation 16.4, and the y of s of 1 x of s is equal to 1 upon a n raised to s raised to n plus a n minus 1 s raised to n plus n minus 1 plus of 2 a1s plus a0, equation 16.11 and 16.12 established in the general result. Okay, now this is a simple example for transportation lake જોઈ લો. આપણે એક્ઝામ્પલ નેક્સ્ટ લેક્ચરમાં સોલ્વ કરીશું. ઓકે, એન્ડ ટ્રાન્સપોર્ટેશન લેક છે સમ થિયરીઝ. ઓકે, થેન્ક યુ સો મચ.